Neurophysiological theory focuses on how the brain and nervous system influence human behavior. The word neurophysiology comes from neuro, meaning nerves, and physiology, the study of how living systems function. In criminology, this theory suggests that abnormalities in the brain, like problems in brain structure, chemicals, or how the nervous system works, can contribute to criminal behavior. This theory started when early criminologists explored biological explanations for crime. Cesar Lombroso is considered one of the first figures to influence this perspective, although his ideas were outdated. Modern neurocriminology grew stronger through researchers like Hans Eysenck, who connected criminal behavior to difference in nervous system arousal. Adriano Rain, known as the father of neurocriminology, expanded these ideas using brain imaging. Together with Andrea Glenn, Rain showed how areas like the prefrontal cortex and amygdala play roles in aggression and antisocial behavior. Other contributors such as Robert Skagg, Nordstrom, Gao, Peskin, and Nicole Rafter helped develop the scientific, genetic, and ethical foundations of neurophysiological criminology. The basic principle of neurophysiological theory is that criminal behavior may result from biological problems. These include impaired brain functioning, chemical imbalances like abnormal dopamine or serotonin levels, and neural development issues caused by genetics, injuries, or environmental factors. This theory doesn't remove personal responsibility. It simply shows that biology can influence behavior, especially impulsivity, aggression, and poor decision making. According to this theory, crimes occur because certain individuals may have neurobiological vulnerabilities. For example, if the prefrontal cortex, which controls judgment, self-control, and decision-making, is underdeveloped or impaired, an individual may act more impulsively or aggressively. Abnormalities in the amygdala can affect emotional regulation, making someone more prone to hostile or violent reactions. Chemical imbalances in the brain can also lead to antisocial behavior. These vulnerabilities don't automatically turn someone into a criminal, but they can increase the risk, especially when combined with environmental factors like poor upbringing, trauma, or social pressure. In short, neurophysiological theory explains crime as the result of brain-based problems that affect control, emotion, and behavior. By understanding the neurophysiological influences on behavior, criminology can develop better prevention and rehabilitation strategies. This theory helps us recognize that crime is not always just a choice. It can also be shaped by how the brain works.
Imagine if your head hits the wall while you're running in full speed. You probably feel a very bad pain. But what if an iron rod is pierced to your brain and that makes you look like a human skeleton? And with that, let me introduce you to the real-life Phineas Gage story that is relevant to the neurophysiological theories of crime causation.
While Phineas Gage was not a criminal in the typical sense, his famous 1848 case provides a classic, real-life illustration of the link between frontal lobe damage and personality changes relevant to criminal behavior. This video that you can find in YouTube stated a detailed information about the Gage story, and let me just summarize it for y'all. This is a fictionalized dramatization inspired by real-life situations. scenario here is Phineas Gage was a respected railroad foreman until an explosion drove a large iron rod through his skull, severely damaging his left frontal lobe. Phineas Gage reportedly felt little pain immediately after his horrific accident due to a combination of shock, adrenaline, and the brain's natural painkillers, the endorphins. Additionally, the brain itself does not contain pain receptors. Tamping iron created a path for excess fluid to drain, which relieved pressure and prevented further brain damage. Additionally, the location of the injury, primarily in the frontal lobe's white matter, may have been crucial, as white matter could regenerate, and the injured's specific trajectory avoided other critical areas like the cavernous sinus. His recovery was also aided by his doctor, Dr. John Harlow, who provided excellent medical care, including treating a severe infection that developed in the wound. He miraculously survived physically, but the incident profoundly altered his personality. He regained his strength within a few months and returned to work within about 2 years. His friends reported that the once capable and well-mannered man became fitful, irreverent, indulging at times in the grossest profanity. A child in his intellectual capacity and manifestations, had the animal passions of a strong man.
So Gage's case for the first time demonstrated that the frontal lobe is very crucial for self-control.
So here, frontal lobe has a lot of functions in your brain, and once damaged, our ability to control our impulses and adhere to social norms can lead to socially inappropriate and aggressive behavior, traits often associated with criminal conduct. This directly illustrates the neurophysiological principle that physical abnormalities in specific brain regions can fundamentally alter personality and behavioral control. This theory suggests that crime isn't just about making poor decisions or being a bad person. It's also significantly influenced by what's going on inside the brain, the mix of your neurology, how your brain is built and wired, and psychology, how you think and feel. Think of it this way: your brain is the hardware, running your personality and behavior, the software. If the hardware has problems, the software might run incorrectly, potentially leading to criminal behavior. Key things that can influence this: brain structure. Differences in key areas like the prefrontal cortex, which controls impulse and judgment, can affect decision-making and emotional control. Neurodisabilities, conditions or damage that impact brain function. And interaction. Crime is a result of a complex interaction between your biology, your psychology, and your environment, such as trauma, poverty, and some others.
Gage lived for nearly 12 years after the accident in 1848 and died in 1860 because of his seizure.
Why this theory matters today is because it changes how we see crime. Instead of only punishing offenders, the neurophysiological theory shows that some behaviors may be linked to brain problems. This means the focus can shift for treatment like therapy, medical help, and strong support systems, not just imprisonment. But it also raises serious questions about responsibility and ethics, because we must be careful not to judge or label people based only on their brain biology. Overall, this theory reminds us that crime is not caused by just one thing. It is influenced by the brain environment and life experiences working together.
The neurophysiological theories of crime causation offers a vital, nuanced perspective that pushes current issues in criminal justice towards a more humane and objective practices.